Again, ratio test, let's take a look at it. Limit, n goes to infinity, absolute value, minus 3 to the n plus 1 times x minus 4 to the n plus 1 over n plus 1 squared. What are we going to do? I'm going to divide by this or multiply by its reciprocal. The reciprocal is n squared over minus 3 to the n x minus 4 to the n. All right? Half the battle is just writing it down, by the way. Let's simplify it. Looks relatively simple. And what I mean by that, if I look at this over here, that's going to be minus 3 to the first power, and the absolute value of minus 3 is just 3. I'm going to pull that in the outside, by the way. Whoops. Let me do the x now. What do I get? X to the n plus 1 over x, I'm sorry, x minus 4 to the n plus 1, x minus 4 to the n is just going to be x minus 4 on top. Okay? And then the n squared over n plus 1, I'm going to write it as n over n plus 1 quantity squared. And what does that limit equal? Well, certainly I got the 3 in the beginning, and as n goes to infinity, that n over n plus 1 goes to 1, and 1 squared is 1. So I just get the absolute value of x minus 4 there. That's going to be less than 1. And what I need to do now is, kind of solve that inequality, which is relatively simple to do. Let me write it over here. And that's going to be x minus 4 is between 1/3 and minus 1/3. I'm going to add 4 to all sides, by the way. By the way, 4 is the same thing as 12/3. So I'm adding 12/3 or 4 to all sides. What do you get? Well, certainly an x in the middle if I add 4 to that. And if you add 12/3 to 1/3, you would get 13/3. And if you add 12/3 to minus 1/3, you get 11/3. All right? Now, what's our question in the interval? Which means I got to test the endpoints out. Now, let's put that down and see what we get. Well, let's test out 13/3 first. Say, what happens when x is 13/3? Okay, we're plugging it in here. You still get minus 3 to the n. And remember, 13/3 minus 4. Well, 4 is 12/3, so it's 13 minus 12, which is minus 1/3. To the nth power, we'll take care of that later, over n squared. I'm going to keep moving through this. This is n equals 1 to infinity. And what do you get on top? Well, it's going to be minus 3 times minus 1/3, which is 1 to the n, which is just 1. So it's 1 over n squared. So this is a convergent p-series. Let's put our little line here. That's good. Let's try 11/3, see what happens. What do you get? Like if I try x equals 11/3, we would get the sum, n equals 1 to infinity, minus 3 to the n. And 11/3 minus 4 is going to be minus 1. I'm sorry, did I say it right? 11/3. You know what? I think I did the other one wrong. 13/3. That's plus. Sorry about that. That was minus. Sorry about that. Made a mistake there. To the n. Let me make sure I said that right, by the way. 13/3 minus 12/3 is positive 1/3. I made a mistake there, and I'm glad I caught it. And that's a convergent p-series. It's alternating, by the way, but it's still a convergent p-series. All right? It's absolutely convergent, all right? So what do you do over here? Let's take a look. That's going to be minus 1/3 over n squared. And what does that give us? The sum n equals 1 to infinity. This is n. 1 to the n, which is 1 over n squared, which again is a convergent p-series. All right, we include that one as well. What's our interval going to be? 11/3, inclusive, touching it, up to 13/3, inclusive, touching it. Let's see if they wrote that down. Mistakes happen. That's why you look at a key. So it says 11/3 to 13/3, inclusive, which is what we arrived at as well. Thank you.